Hello everyone, in this tutorial I will show you how to add the zombies to the Lyra template of Unreal Engine 5 to make it attack the player, make it give some loots when they die, and finally make it spawn only at night. So let's go! The compilation took about 5 minutes. Now we will add the third-person template to the Lyra project, so open the Lyra strategame.u project. When the Lyra project is open, go to Content Browser and click on Add, then Add Feature or Content Pack, select Third Person and click on Add Project. You will see here a new folder, Third Person. Open the Map folder, click on the Third Person map, Ctrl-C to copy it, then go to Plugin, Shooter Maps Content, Maps and paste it here. File, Save All, open the Third Person map. In the World Setting tab, go to Game Mode. On the default gameplay experience select, choose B Shooter Game Elimination. And on the Game Mode Override, select None. Save it. Now we will select the player start and we will delete it. Now we will need to add a new player start which is compatible with Lyra. So go back into the content browser, click on All, then search for Lyra player start. If you don't see anything in this view, click on Settings and then Show C++ Classes. Drag and drop it where you want into the level. You can, for example, add a 4-player start. Save it. If you want to have this map open when you open the Lyra project, click on Edit, Project Settings, Maps and Modes, Editor Startup Map, choose Third Person Map. Choose the good one in the Shooter Maps folder. Now we can test it. So click on Play. Okay, so the blue player should be, the red player shoots the blue, and I shot it. Still working. To create a new component, go back to the Unreal Engine. Please note that any C++ classes must be created with the Unreal Editor. So go to Content Browser. If you don't see C++ classes, remember, click on Settings, Show C++ classes. Lyra game. Right-click, New C++ class. Click on Classes, and we will create a class of type Game Framework Component. Go to Lyra Starter Game, Source, Lyra Game, and here you can create a new folder. I will call it Components. select folder, and if you click on public or private, it will be created. The header file and the source file will not be in the same folder. So personally, I prefer to have it in the same folder. I'm not a C++ developer, so I don't know if it is a good practice or not. But in my case, I prefer to do like this. And we will create a health component. This component will manage the health of the zombie. So its life points will be managed here, and the same and the take damage action will also be managed here. Now we will add some logic to the component to manage health and the death of our character. So in the uClass attribute, we will add blueprintable blueprint spawnable component. Here we will declare the delegate for the dying event. Declare dynamic multicast delegate if die delegate. So in this way, we will replicate the death of our character. This name will be used later in the class. Now for public method and attributes, we need the constructor. So I copy it from another project. Const f object initializer, object initializer. If we need in blueprint to override the begin play method or in C++, we'll do this. Begin play override. For the replication, we will need this void up get lifetime replicated props. And we need two methods. The first one to set the current health, and the other one for taking damage. But we want this function to be blueprint callable. So set current health and to make it reachable by blueprint, we will add u function blueprint callable, and we will add a category to find it easier. Category. Now the take damage method. And now for the dying event, we will add a U property. Yep. And now we will take this name fdi delegate on die delegate. So in this way, we declare the event in C++, but we will implement it in Blueprint. Now we will have protected attributes and the method. So we need max health, so float. And for this value, we want to not to be edited in Blueprint, but accessible for default property. So we will add a U property, edit defaults only, and category health. We need the current health variable, float current health, and we need it to be replicated. So now we will add two functions to replicate the current health value. Also, U function unwrap current health and void on health update. Okay, so for the declarations, it is finished. So now we will implement all these methods. So hop, I will create all the implementation like this. So hit on your keyboard, control point, create a definition of begin play in health component.cpp. And I will do this for each method. Okay, so for the constructor, we need to call the parent and for replicated variable, we will need to add these two lines. Primary component tick dot b start with tick enable equal false. Primary component tick dot b can never tick equal false, and set is replicated by default true. And for debug purposes, I will add some default value here for our max health. And our current health. don't know why I have this error, but it may disappear with a compilation. For the begin play method, we call the parent. For the get lifetime replicated props, we call also the parent. And we will add this, the rep lifetime with this line. We say that we want the current health to be replicated. For the rep lifetime, we need because I am in the same folder between the header and the implementation. In the include file, I have to remove the component here. We will include net unreal network. For set current health, we want this action to be executed on the server. So if as authority, then current health equals to fmat clamp health value to be honest, I don't remember what does the clamp method do, but I copy it from a Lyra project. Then we call on health update. So we will implement the on-health update now. For the on-health update, we need to get the attached pawn of the component. Pawn my pawn equal cast a pawn get owner. If my pawn exists, so if my pawn, and also if its current health less or equal to 0, it will be dead. So we will call the on-die delegate. On-die delegate. And we want to send this the message of the character is dead to all the clients. Broadcast. For the function on current health, it will be easy on health update. And now for the function take damage, where is it? I don't edit take damage. float we will calculate the damage applied to sorry, we will calculate the new health of our character depending of the damage taken here. So float new health equals to current health less damage taken. We call set current health of new health, and we will return the new health. Okay, so I think it is done for this component. We will try to compile it to see if this error disappears. Okay, so I don't understand why it didn't work, but I closed the Unreal editor, I closed my solution, I reopen it. I did a right click on the Lyra state again, clean and build, and then the compilation worked. So we will have finished with this component. So now we will create another component. So we need to reopen the U project. We will create the component which handle the loot when our character is dying. So we'll back into the C++ classes, Lyra game. Now we should find our component folder, new C++ class. Again, we will select the parent class game framework component. Next, library game components. Okay, and I will call it spawn item component. So now the compilation is finished. We can close the Lyra starter game. Whoa. Okay. So, and we will create our spawn item component. Just like before, we will need this, copy, paste. We will need the constructor, the begin play. So, public what we want to do here is when the character is dead, we want to enable this component. So we will do single method you function blueprint collab. I want to call this method from blueprint, so I did this and we'll name it void enable component. Protected. For debug purposes, I will add a U property edit defaults only. Category equal debug. We can delete this variable later. It is just for testing. For example, in a FPS game, when you kill an enemy, sometimes you will loot something, so it depends of luck. So we will create a new variable, float change of apparition. Well, looting chance, and it will be a variable accessible for blueprint with default only. Okay, and also if I take an FPS, some FPS games, sometime you can loot ammo, sometime life, etc. So we will create an array which contains a list of items we can loot from this enemy. So we create a tier array of T subclass of class actor items to spawn. And again, your property edit default only category data. And in private, we will create a variable of type boolean to see if the component already has been enabled. With this way, we can block the activation to be activated once. Now we will see the implementation. So we need the constructor. The begin play and the enable component. In the constructor, we will call the parent we will need this primary component tick, be start with tick enable false, be can never tick false, and enabled equals false. For the begin play, we need the parent. If we need to add some logic, we can do here, but we don't need for now. And the enable component method. So if the component already has been enabled, we don't do anything. So return. If the debug mode functional okay, enable with caption on. If debug looting chance equals to 1. So in this way, each time an enemy will dying, a loot, an item will be spawned by the loot. So to manage the random value of looting, we'll create a new variable, random looting chance equals to fmath f run range to zero to 1. If random loading chance, sorry, less equals to looting chance, we will spawn an item. We will create a random value to spawn, for example, health or ammo. So int item index equals to f math run range. The difference between f run range and run range is this one use a float value. So we need to have a value between 0 and the number of items in our array less 1. So we can take it and less 1. And now we will spawn the item of and now we will spawn the item corresponding of our array with this index. Now we will spawn the item corresponding to this item. Now we will spawn the item corresponding to this index of our array. So, up, we can copy this and paste it here. Item to spawn equals to items to spawn, and we need item index. We will now we need to define some spawn parameters. So f vector we want this item to be always a spawner, so spawn actor collision handling method always a spawn. Now we need to get the location of the owner to spawn this item at this location. No, I think I forgot to define something. Yes, I forgot to define a variable for the owner. So actor we don't need to cast it here because we only need its location and rotation. Get actor location. And now we can spawn the oh not a vector but a rotator. We can spawn the actor. So we spawn actor. We need the class to spawn. We spawn at location with this rotation, and we need the spawn parameters. For debug purposes, we can show a message if there was a problem when spawning. And up, engine. Add on screen debug message for 5 seconds. And it's done. Okay, so we need to compile it. I did a mistake here, so we need to correct it with a C like this. Compile it, and when it's done, we have finished to do C++ classes. So for the next part of this tutorial, we will see how to add the zombie. Go to Mixamo, click on Browse Characters. Search for the character you want, for example, a zombie, and I'll choose this one. Click on Download, format FBX binary, pause, T-pause, download. you will have a new FBX. Click on animation and choose the scary zombie pack. I choose it because it has a lot of animations. And again, click on download, FBX binary, typos, download. Now go back to the Unreal Engine and create inside the folder all content, create a new folder called zombie, and in this folder create two subfolders called animations and skeleton. Open the skeleton one and open, open the download folder within we have the FBX and drag and drop it inside Unreal Engine. Click on Import All. File, save all. You can open, for example, a skeletal mesh. Oh, I don't know what it is. Translucence, but we will try to work with it. In the animations folder now, select all the animations in the downloaded animations from Mixamo, drag and drop it, and don't click on import all, select a skeleton, which is the skeleton you did just before. Click on import all. And this concludes the first part of the zombie to import character files. Before we start the second part, I had a problem with translucency about my character. So to fix it, I went to the skeleton folder and opened the three materials we have here. And I broke the link we had in RGB opacity. I did it for the three materials. So it is a bit ugly, but it is okay to get the concept. Now we will create the animation for zombie. So right click on the skeleton, create anim blueprint, name it ABP for animation blueprint, and zombie. File, save all, open it. First of all, open the event blueprint update animation. We will get the speed of the mesh because if speed is greater than 0, our zombie is walking or running. If not, if it is equal to 0, our zombie will be idle. We will create a new variable. We will name it speed of float type. So we will get the node try get pawn owner, get velocity, vector length xy, and then the result will be connected to the set speed node. So on every tick, the animation will be, we will update the speed of our character. So now go to the anim graph How it is working? How to explain this? Here is a result of the calculation of the animation. So for example, if I take an animation and I compare it, our zombie will do this animation. But in our case, the zombie will have a lot of animation, walking, idle, attacking, etc. So we will use a state machine. So right click on the blueprint and select new add new state machine. Connect it to the output. Name it, for example, basic locomotion. In our state machine, we have an entry point here, which will be connected to the main status, or the main state of our zombie character. We will add a new state, which is called the idle state, and we will connect it. So when the zombie is spawned on the ground on our map, the animation blueprint will take the state of our locomotion to output a result. So it will be this state. We will need to connect an animation here. So now if we drag and drop a zombie on our map, the ideal state will be triggered and we will see this animation. But now our zombie need to run and later attack our characters. So we need to add a new state. It will be the running state. We can select an animation, zombie run. Okay. But to switch off these two states, we need conditions. We will not trigger the animation of running if our character is not moving. So we will add an arrow in this way, the same in other way, and the condition of idle to running is the speed is greater than, for example, 0.1. Okay. And in the other way, oh, sorry. If speed is inferior is less equal to 0.1, we can enter transition. So in this way, if the zombie is not moving, we will play this animation. If our zombie is running, speed will be greater than 0 and the animation running will be played. Now to test our animation, in the zombie folder we will create a new blueprint class and select all classes. We want our zombie to be a character. Okay. We will name it BP for blueprint zombie. On mesh, select our skeletal mesh. So zombie. Up. We will need it to adjust its location in the capsule component. 90 degrees. Okay, compile, save. And in the animation panel, select use animation blueprint and anim class ABP zombie. So now, if we are back to our map, if we place a zombie here, we can see our zombie, which is in an idle state. Now we will add the else component to the zombie and the death logic. So to do this, edit your biped zombie, then click on component add and add the health component we just created. You can check the max health value here and change it if you want. Also check the component replicate is checked. We will need a variable here, is staying a boolean. So we start with event begin play, and we will bind the onDie delegate to a new event implemented here. So we take the health component, bind the event to onDie delegate, and here add custom event, and we will name it onDie delegate event. We create another event, and in details, replicate, select check on my node project, multicast. And then here call die event. So we need this variable to execute the code once. The character is dying once. It is not dying multiple times in a few time. So if it is not dying, we set it to true. And we will disable collisions. Set collision response to channel. So in this way, when you work on a zombie, you will not be blocked. Channel pound, new response, ignore. We will add a delay. It will not moving for 5 seconds. And then we will totally disable all collisions. Set collision response to all channels. New response, ignore. In this way, the zombie will fall behind the ground. We add a delay for 3 seconds to let the time to the zombie to pass through the ground, and then we destroy it. And open the Visual Studio solution and search for Lyra health component. Here we are going to add a new method to apply damage to the character. So it would be uFunction blueprint callable. We're gonna to set a category. Lyra health. And it is a void apply damage float damage. And we need to implement it. Oh, sometimes I really love Visual Studio. So for the implementation, void Lyra health component apply damage float damage. So if damage less equals to 0, we don't do anything, so we can return. In the other way, here we're gonna to call the existing method of taking damage. So we need to const t sub of gameplay effect. I will check, maybe we have an example. Yes. We're gonna to copy a part of this method. So we need this, we need also this till here. Up, all of this. Past it. We will change the tag. Gameplay damage. And call the spec object set by color magnitude f Lyra gameplay. Maybe we have an example, another example here. So go back to your damage test script and copy the last two lines and paste it here and replace here the damage amount by your damage here. And I think it is done for this part, so you can save all and compile it, and when it is completed, you can open the new project. We also need to enable some collisions here, so click on capsule component, collision present to custom, collision enabled query only, object type pawn, and so visibility block camera ignore, Lyra trace channel weapon, weapon capsule and weapon PT to block. Here, physics body ignore, vehicle ignore, destructible ignore. Now we have finished with this blueprint. So go back to your content browser, go to all, content, weapons, and open GA weapon fire. Find this block, process target data once ready. And here between the branch and the execute gameplay queue with paramount owner, we will add a sequence. We keep logic if the hit actor is a Lyra character, but we will add some logic for zombie. So we take the hit actor just here, get component by class, we will take the health component, we check if this component is valid, and if it is not valid we don't do anything, but if the hit actor has a component, a health component, we can call the take damage methods. And for example, here for damage chicken, we will put 60 to make it die quickly. Now we can test the logic. So the zombie is dead, but we forgot an animation. Oh yeah, just after the die event of the zombie here, play animation, and select zombie death. And now it should fall when it dies. So it falls, it waits for some few seconds, it falls on the ground and it disappears. Now we will create the object that the character will see in the world. So right click, blueprint class, actor, okay, call it BP health pickup for example, and open it. Inside, go to the viewport section, components, add capsule collision, and in capsule collision we will check that here we have overlap all dynamic. Add another component, static mesh, I will call it mesh, and select the object you want to be visible in the world. For I will choose SM health path part. Okay, yeah, we can do like this. Go to the event graph. We don't need event tick. We don't need begin play. We only need actor begin overlap. On the other actor, try to cast to be hero default, which is the parent class of the Lyra character. And if the cast is okay, so we will get ability system component. If the cast fail, we don't do anything. And here select apply gameplay effect to self. Okay, and gameplay effect class select GE instant heal. We'll select the one you want. I will choose the big one. And it is done for this loot. Okay, compile, save. Go back to your content browser, duplicate this pickup. So Control D, and I will call this one BP ammo pickup. Open it. For the match, I will change it for is there an ammo or something? No, okay, go for a pistol. Then we delete this, we keep the cast to be hero default. Oh, we'll check something for be hero default if it has an inventory of, or if it is on another blueprint class. Be hero default. It doesn't have an inventory, so we'll do with another way. We will cast it to a pawn with convert to pure cast, get controller, get component by class, and here we select Lyra and the inventory manager component. We will promote this to a variable inventory manager. We check if this is valid. Oh no, we don't need this. Here, select find first system stack by definition and select here AD pistol. Now promote this to a new variable. Existing weapon instance. In fact, we could already cast this to the Lyra character, sorry. So cast to oh, yes or not? I don't. No, sorry. Um, so we will create a variable for this. We can call it pawn. And here get as pawn. Now we can cast it into B hero default. Yet it is a bit tricky. We take the existing weapon instance, add. Oops, sorry about that. Add stat tag stack. Okay. For the tag, we can keep this like this, but for the stack count, we will do this. Get stat stack count. And we will check. Oh, sorry, here it's a bit difficult for me. Lyra dot shooter game dot weapon spare ammo. And here for this one, Lyra dot shooter game dot weapon spare ammo. Here get default stat from item def. Here you select ID pistol, and again for the tag Lyra dot shooter game dot weapon dot spare ammo. Subtract, and the result must be connected here. And then we need to destroy the pickup. So we get when the loot is touched by our character, it is cast in a pawn. We get the controller, the component inventory. We get data for the pistol. We cast to the Lyra character, and then we calculate the new ammo we have in our inventory. So we have finished with this, so compile and save, but if you have this error, I think we need to change the mesh here, so we will try with it will be ugly, but with a box. No? Okay, we will keep it like that and correct it later if needed. So go back to your content browser, go into the zombie folder, bp zombie, and then we need to add the spawn item component. Open the default variable, debug check to true because we want to spawn each time. If not, we can select 50% of chance of apparition. We will add two items to spawn. The first one will be BP health pickup. The other one will be BP ammo pickup. Compile, save. But for this one, I'll check. I think we need to do a last thing. Yes, for the BP zombie, die if it is not dying. Here we can add spawn item and then enable component. So now if I don't forget anything, we can try it. Okay. The zombie. We have an ammo backup which is spawn, so see my ammo. I have 12 and 24, and I have 12 and 48 ammo. Okay. We can do another test to see if the random is working. We add some zombies. To try if we have the health component. Perfect. So if I take damage, and now I walk into my health components, my health go back to full. We need to create a few more blueprint classes, so for the first one will be a controller for our zombie blueprint class. Parent class, we will select Tuto crawler AI controller, and we'll call it zombie AI PC. Okay, we need to create also artificial intelligence a behavior tree, and we will call it BT for behavior tree zombie, and another one a blackboard BB zombie, and open zombie AI PC. Go to the event graph. We don't need event tick. We only need the event begin play, and here run behavior tree and select BT zombie. With this, use blackboard and select blackboard zombie. Okay, compile, save, and go back to the content browser. Now open the blackboard zombie. The self factor, we keep it. We will add 2 keys. Oh, sorry, I forgot to create. We need to create a new enumeration. So right click, blueprints, enumeration, and we will call it zombie AI state type. And we had the 3 states. The first one idle, the second one chasing, and the last one attacking. Okay, save, close it. Go back to your BB zombie, add a new key of enum type, call it AI state, key type select click here on the little here, enum type zombie AI state type. Add the last one, which is an object. Call it AI target. K-type object. Click here, base class, B hero default. Now save your BB zombie, go back to your content browser, and we need to create other blueprint classes which will be used in the behavior tree. So the first one will be a blueprint of type BT service blueprint base and call it BT service set chasing. Create another service so we can copy and duplicate this one, and we'll call it BT service update target. And finally, recreate a blueprint of type BT task, blueprint base, and we'll call it BT task attack. Save all, go back to your behavior tree, drag a new arrow and select selector, and here right click, add service, and search for your update target service. Save all and open the service update target. Open full blueprint editor. We need to create 4 variables. The first one is perception distance of type float. This one will define the distance where your zombie can see you or not. The second one is AI target of type blackboard key selector, and click on the eye here for the 4 variables. The next one is AI state. These variables will be seen by the behavior tree. Blackboard key selector, and the last one, attack distance of type float. This will be to set the distance of the range of your attack. For example, if the zombie had a gun, you could set a big distance here, but it only has his arms, so it's only a close distance. Compile, save. For the default values here, perception distance default value we can keep 0 here. For the AI target, no default values. I state same, and attack distance we will set to 150. Compile and save. Now here, event receive tick AI. Do I have this method? No. Oh, I forgot to create also functions. So create first function set state with an input state of type zombie AI state. Drag and drop here the AI state. Set blackboard value as enum. Okay, state. The next function will be get state, which will have an output state of type zombie AI state type. Drag and drop AI states. Get blackboard value as enum. Hop. Okay, compile, save. Another function is target valid. Here we will need to create a new local variable self-reference of type pound. Pound object reference. And here input controlled pound of type pound. Drag and drop the set reference. Oh, I select the wrong type here, so I will do like this. Promote to local variable and call it self reference. Select AR target. Get blackboard value as object is valid. Create a branch and link this and this. If false, we can add a return node. We need to create an output value is valid of type boolean. So we want here to determine if the target is valid, means that the target of the zombie is a Lyra character. So if it is not and here we check if the AI target has a value. For true, so if it is valid, we need this. Cast to be hero default. Link this. As a B hero default, we can convert to pure cast. As a B hero default is dead or dying. Hop. If it is dying, the target is not valid. But if it is not dying, we can add here as a new return node. And here we can select get hop, get your self-reference, get actor location, oh no, sorry, first get the behavior default, get location, get the location of your zombie, which is the self-reference, calculate the distance between them, distance square, I guess it is, no, it was not this one, but distance squared vector. If the distance is less to the perception distance squared. So if the distance is less to the perception distance, the target is valid, but else it is too far away to chasing him. Compile and save. Now open the DBT service set chasing. Oh no, sorry, I forgot something here. Create a new function, search and set target. An input, we have the self-reference. Object type of pound. Promote to local variable. Oh, down here and here self-reference. Create a new local variable of type, call it available target of type be hero default and select array. With this variable, we will get all the Lyra character of the map and test for each of this one if we can have a target in the perception distance of the zombie. So get clear get all actors of class be hero default. for each loop. On the loop body we have is dead or dying of component. If true, we don't need to add it to our available targets. If false, we need to get the distance. So we can go back to is target valid and copy this. Add a branch here. So if it is not dying, we test the distance, and if the distance is less equals to the perception distance, we can add it. We can add this element to our array. Array add true available target. And when it is completed, we need to create a branch. We test if it is empty or not. If the array is empty, we don't have any target to check, so set blackboard value as enum. AI state, drag and drop it, get state. Here select key, literal, zombie, AI state type, literal enum zombie AI state type, and select idle and link it. And if it is not empty, here we can set blackboard value as object. AI target, and here we will select a random element of our array, random. So if we have more than one players, the zombie will attack randomly the different players. And for the zombie, we need a new literal enum of our zombie state, enum chasing, AI state get, set blackboard value as enum, and link this. Oh, I did a mistake. Oh, sorry. Here I selected BeHero Arena, but it must be BeHero default. So I need to do this. And compile, save. Okay, I need to do this here again. Is empty. And here, random element. Compile, save, and this time it is okay for this function. Go back to the event graph. Event receive tick AI. Now we can call get state. AI state switch. If we have an idle here, we can search for a new target. Oh, we will promote this to a variable. So if you don't want to create a local variable, you could replace the local variables in these functions by the self pawn here. Set get here. Now if the state is chasing, we check if the target is valid, because if the target dies meanwhile the zombie is running to its target, we need to find another target. Self pawn branch. So if it is not valid, we can search and set a new target, and else we can go back to is target valid, copy this, so we can make this into a function. It will be better. Paste here. For the first get actor location, drag and drop a target. Get blackboard value as object. Cast to be hero default and not a be hero arena. Convert to pure cast. Link this. Here we need a branch. So we check the distance again. But here we need to change perception distance by attack distance. So if the zombie is close enough to the character, we can attack it. So we can call set state attacking. And because I renamed it self pawn. Okay. And it is done for this blueprint class. Now we can edit the BT service set chasing. We don't need a function, we only need one variable, AI state of type blackboard key selector, event receive tick, AI state get set blackboard value as enum. We need the zombie state enum. Not a switch, but a literal. with the state attacking. Okay, and this is done for this service. And okay, now open the BT task attack. We need two variables, AI state of type Blackboard key selector, a variable AI target. Click on the eye here, Blackboard key. I will check this because I think no, that's okay. We need three events. The first one is Unreal event. So event receive execute AI control point to cast to be zombie. If the cast fail, we can call the event and then execute. Why I don't have it? Oh, because I didn't create it. Oh, okay. Create a new custom event and execute. Select AI state. Set Blackboard enum value as enum. Some by AI state type. Literal chasing. And finish execute. And click on success. So here, with the end of the execution, after give an attack, the zombie go back to the chasing mode. Up, we don't need this up, so I can put okay. Cast to go back to your event receive execute AI, cast to BP zombie, add a branch. And now we need to test if the zombie is dying or not. So if it is not equals, no, not boolean. So with this, I test if the zombie is valid. So if it is not, because for example it is dying, we can call and execute. Else we need the AI target, get Blackboard value as object, cast to actor, if the cast is failed, you can call and execute. Else, we need to get a zombie. or we can promote this to a variable. It will be easier. We don't have created the attack. Nope. So here we will have the attack node, but we don't have created in the zombie, so we will create just after. We can finish to create the rest of this function. Set timer by event. This will manage the frequency of the attack. For me, it will be 1 second. And here, add custom event, apply damage. And here, we need to get the target. So cast to be hero default. If the cast is failed, you can call and execute. And here, as be hero default, you can call apply damage. Base damage, for example, you could set this value. And damage class, we need to select, for example, damage type. I did a mistake earlier. This timer is the time between the zombie is close to the character and the attack. Now we add a delay for the frequency of the attack. I calculate this value for me. But you will see this with the animations of the attack. And here we can call and execute, but we need a new node here, like here. So compile, save, go back to your BP zombie, and I'll check even begin play, bind event, okay, this it is okay. The die event, we don't need something more. We need to add two custom events. The first one is start attack. The second one is end attack. We need to get the variable is dying. No is dying, but is attacking. So we need to create a new variable of type boolean. And here, start attack is attacking to true, and attack is attacking to false. Compile save, go back to your BT task attack. And here we need to add start attack. Okay, sorry, no, I don't forget. Apply the image, and here, just after the applied image, we have the delay, and here, completed, and attack. And it is done for this task. Now we can go to the behavior tree and make a basic AI. So here at the selector, add service, update target. We will set default values of perception distance. We can set to this AI target. Target enemy, AI state. Oh, I don't have. It doesn't use a good blackboard, so behavior tree. Ah, yeah. Select here the BB zombie, and here AI target, AI target, AI state, AI state. Attack distance, I will keep to this value. Oh no, this value. And we need to create 3 arrows each for an arrow for each AI state. So no, it is not a selector. Wait for 3 seconds. And add a decorator. Oh, sorry, this part is very difficult for me. I don't remember how we select the different menus. Add decorator. Backboard. And here select, you can call it is idle. We need to notify observer on result chance, observer abort self, blackboard key AI state is equal to idle. We need to do this, something like this for the other states. AI move to, add decorator blackboard, chasing, abort self, AI state is equal to chasing, and the last one, BTT task attack, add decorator blackboard, attacking, abort self, blackboard key AI state is equal to attacking, and here for BT task attack AI state, AI state, AI target, AI target. I don't know why I have this error, but I think this is okay like this. Now we need to link the AI to the zombie. So go back to your BP zombie, click on the self here in the components list. In the default, here you need to find the pawn section and auto process player disabled. Autoprocess AI playstore world or spawned AI controller class. Select the zombie AI PC. Okay, and now we can test it. It doesn't move anywhere because I forgot again to add something which is called volumes nav mesh bounds volume. This volume determines where your AI can walk or not. So we need to be bigger, bigger, bigger. If you hit P key on your keyboard, the green path is where your AI can walk. Before testing what we did here, we need to fix some things I forgot. So go back to your zombie folder, open BT zombie, and here in the move to node, I put self factor in black bracket that it is AI target. Save it and close it. The next one is in the loots, BP health pickup. In the node actor begin overlap, after the node apply gameplay effect to self, add a destroy actor. Compile, save, close it. And now go back to your zombie folder, skeleton folder, open ABP zombie. We are going to add the animation of the attack. So go into the event graph and add the begin play event. Try get bound. Oh no, we are going to set this into a variable. Cast to be zombie. Whoop. And promote this to a variable. Now in the blueprint update animation, we get the speed and we need to check if the zombie is attacking. So here at the sequence, the first node here is gonna be the speed, so we don't need to change this. But here, drag and drop self ref and test if is valid. If it is not valid, we don't do anything, but if it is valid, we check for the is attacking, get is attacking, and promote this to a variable, and link it to is valid. So now the animation can see if the zombie is attacking or not. That's all for the logic of the event graph. Now we are going to edit the state machine of our zombie. So go back to your basic locomotion. We need to add a new state. We will call it attacking. In this one, we need to drag and drop the zombie attack animation. Okay, go back to your basic locomotion. We need to add the transition states. We need to add this, and again in the other way. So zombie run to attack is gonna be is attacking equals to true. In the other way, if he stopped attacking but still running, he's attacking. He's not attacking. And the same here for between idle and attacking. For here is attacking, and here is not attacking. Oop. Not boolean. Okay, so I'm gonna to test it to check the animation. I did a mistake earlier in the tutorial, so I will not take any damage. We will fix it just after this. As you see, here basically attacking the player, but it doesn't take any damage. And also, I think in the AI we will need to add a new state is being, or maybe fix something because it was moving when dying. In your Cotton browser, search for zombie BP zombie. In the components, click on character movement and search for use controller desired rotation. If it is not checked, please enable it. Compile and save. This option allows to the zombie to have a new rotation when it turns. If it is disabled, the zombie will look always in the same direction. And now open the BT task deck, and we're gonna to replace this apply damage node. Here, take the as be your default, search for apply damage with the Lyra health component. So here, Lyra health, apply damage health component. For example, here you can take back 35. Link this, compile and save. I added some few zombies and I changed the place of the start points to see if the zombie is really attacking the character. Now we can test it. The zombie is killing me. I'm going to the red player to see this. Yes. Oh, I should disable the blue players. That was a test. Yes, this zombie, for example, is attacking. So this is done for this part. Now we're going to add the spawner to our map. So for this, delete all the zombie present on your map. Create a new shape or a static mesh of the spawner anywhere you want. It will be the place where the zombie will spawn. For me, it will be here. And finally, open the level blueprint. Take your static mesh for the spawner and drag and drop it into your event graph. And now we're gonna to spawn a zombie or multiple zombies when we hit a key from our keyboard. So I will add input J. When I hit this key, I will spawn many zombies. So I will add a random render integer in range. So min it will be 1 zombie, maximum will be, for example, 5. And here pressed for each loop. Not for each loop, but for loop, because we need the first and the last index. The first index will be 0, the last one will be the integer we have here. And here we can call the method spawn actor from class, connect the loop body here. In the class, select your BP zombie. We need a collision handling override. Try to adjust location, but always a spawn. Oh. I think this is no. Get world location. Nope. Get world transform. Yes. So to the spawn transform, connect here the cone static mesh component, get world transform. And this is okay. We can test it. So we have our cone here, and if I press JK, the zombies spawn. One more of them, once, twice, etc. So that's for the zombie part, and to finish this tutorial, we will see how to add the day-night cycle and spawn zombie only at night. Now we will add the day-night cycles. So we need to add here a new light source, but before this, check your directional lights. If you switch on and off, the screen turns black. And rename it sunlight. And we will need to set its location in the world. So we'll go to the details panel. Location 0, 0, 0, okay. Rotation set 0. Minus 90. And for the z-axis 0. You can set the scale like this. And user params, it is okay. Duplicate the sunlight and call the new one the moonlight. And for this moonlight, in the details panel, Um, Location can be this, rotation 0. Um, you can you see here you can test your different values. I tried 90, but I prefer 85. I don't remember if it longer the begin of the day of the end, but I prefer like this. And here you can set to 0. And because the night light is not as strong as the sunlight, here for intensity you can set it to 2 lux. And you can change the color. I like little blue like this. And here we will try it like this. We will see what we have with this. So file, save all, and go back to your event graph of your level blueprint. So now we can put this into a function. Spawn bees, cut, past, link, compile, save. And now we need the event tick. We need the event tick because each time a tick is done, we need to move the light. So here we will add a sequence. Because here in the first node, we will update the light position, and later in the second node here, so then one, we will update the clock, which will be displayed on the screen. Oh, this promote to variable, because we probably need it later. And we need some other variables here. Day length of type float. It will be set the speed of the day. A boolean is night time. Delta second we have a fit. We need a time variable to time span. A text time of type text. We need also... No, I think it is okay. We will add it some other variables if needed. Compile and save because we need to set a default here, that the default day length 30. So now take the delta seconds, take the day length, multiply. Oops, sorry, I did a mistake. So here, just like that, take the delta seconds here, multiply it to the day length, and now set the new variable delta seconds. After this, Go back to the world outliner, drag and drop here the moonlight, do the same for the skylight. From the skylight, add actor local rotation, add actor. Oh. Add actor local rotation. And here, from the result of the delta seconds, make a new rotator. Okay, disconnect this connection and drag it into the Y, the pitch one. Connect to the delta rotation. Okay, good. And do the same for the moonlight. So here we can copy paste. Okay, target here and here. Okay. Now here we need again the skylights. We will determine if we are on the night or only in the day. So here get actor rotation. Splits the stroke pin. Take the Y in range, float. Min 0, max 100. You can check inclusive min and max. And here set is nighttime. Link this. Add a branch here. And now we will add two more functions here. The first one will be night lighting. And the second one will be day lighting. So open night lighting. Drag and drop the skylight here. Oh, not the skylight. Maybe I did a mistake before. We will check. Yes, here it is not the skylight, but the sunlight, sorry. So, where is my sunlight? So we're gonna do copy, paste, and in the daylighting, paste. Here, take the light component. Oh. Nope. So maybe if we tried like this, set intensity, light component, perfect. Intensity, and for the new intensity, we take here the intensity variable, get intensity, finterp2 current, and we need delta seconds here. Connect this. And we will do the same for the skylight. So here you can't copy this and paste it. Here drag and drop the skylight. sorry, so set intensity, light component. Okay, connect this, and here take the intensity to current and the return value connected to the new intensity here. Okay, compile, save, and open the night lighting. Great, I did the mistake, I reversed night and day, so here call it, rename the light lighting to light lighting 2 and the day lighting renaming to night lighting, and then this one night lighting 2, call it day lighting. Sorry about that. So here we need the sunlight. Set intensity. Oh, I also forgot, sorry. I'm really sorry. I missed something. So here to the first F interp 2, target set it to 0.1, and interp speed set it to 3. And on the second here, set it to 0.01, and the interp speed set it to 5, and here delta second need to be divided by 4. I will check on my other project. If I don't, no, this time it will be okay. Compile, save, and go back to the day lighting. Day lighting connected to set intensity. The skylight will be this, or we can do in meanwhile, so don't have no importance. So here get the intensity F inter 2, current target 2.5, delta time 2, we need the delta second, divide by 4, connect to the delta time, and for the interp speed set it to 8. Connect this, and now we need to do something like this for the sunlight. So drag and drop the sunlight. And again, set intensity. Connect this. Get intensity. F interp 2. Current. The delta seconds must be connected here. And here the target set it to 3, interp speed to 4, and connect here the new intensity. Okay. Now go back to your event graph. Go back here, it is nighttime on the branch. Call the two methods we created. If it is true, so you call night lighting. If it is too false, we call daylighting. And it is okay for this. We're gonna test this. So now you can see it's night. Now it is day. And you can set the speed by setting the day length here. Now we will add the clock on the screen, so create a new function, call it clock. And on the clock we have a lot of things to do. We need delta second, and here multiply it by 240. Okay, we create a new variable, we call it tick of type float. We don't need the default value for this. And here we get the last tick. We add it to this. And we set the new tick value with the result of it. Here we call truncate. Here make time span. Disconnect this pin, connect the return value here to seconds. Here set to 12 hours. And connect the set time node and connect this here. And here we can break time span. Here search for a string append. So string append. We need a 3. Whoop. Click on append pin to add a new node. EC space. Sorry. Here space. Add 2 points. Space. Connect house to CA and minus to the C. And here convert this to text. We need a branch here to connect this like this. And here, if this is not equals, not equal exactly, connect, and here connect text time. If it is different, you can set the new time will be displayed on the screen. And connect here this node to the set text time. Compile and save it. And now we will need to add this text to a new widget blueprint, which be displayed on screen. So go back to your your content browser, sorry, on content. We have a folder UI. You can create here user interface widget blueprint of type user widget, and we'll call it widget blueprint WBP look. And open it. So here we need to add a canvas panel, and we need to add some text. Common text. You can't set its position anywhere you want. I will do to the middle top screen. So here 0, 0, the anchor set to here. So 0, 0 size x 100. So here minus 50 and Yes, like this. I will call it clock time is variable, and into the graph, and here we're gonna to add an event dispatcher. We will call it update time clock event, and here add the bind event to update time clock event, and on the event construct here we can create a new event, add custom event, update time clock. On the event dispatcher, it needs a new input, so here add a new input of type text. We will call it new time. And here you can take in the variables the clock time, set clock time. Oops. Nope, sorry. Get clock time and set text. Connect this, compile and save it, and go back to your content browser and search for B hero default. Open it, go to the event graph. Do we have an event begin play? No, so we're gonna to add event begin play. Add the begin play node here. Create widget blueprint of class WBP clock, and then add to viewport. Okay. And now go back to the third person map to the clock. Call update. We will try like this. Oh no. So we need something else here. So here, go to hero default. Here, promote to variable. You can call it clock UI. Compile, save, go back to the third person map blueprint. So here, call get player pound. Cast to be hero default. Connect this as be hero default. Get the clock UI, and we can here call update time clock event. Perfect. Finally. And here connect the text time here. And now it should work, so we can test it. It doesn't, so I missed something, of course. Go back to your level blueprint. On the event graph, on the second node here, you can call the clock function. Also go back to UI folder WBP clock, and we need to move this because it is on the scores displayed. So we attach it to the right top corner, remove here the text block here, and now it should work finally. Yes, perfect. So we have here we have the clock. To finish this tutorial, we will add a dynamic spawner. The zombie will spawn only at night, so go back to your level blueprint in the event graph and find the night lighting and day lighting nodes. And here create a new boolean variable, as already spawned this time, of type boolean, default to false. For the daylighting, we don't want anything for now, but for the night, we need a branch. Here as already spawned this time. If yes, we don't do anything, but if false, you set it to true, and you can call spawn zombies method. Compile and save, and here you can set it to false. So like this, zombies will spawn once at night, and it will be reseated the day. Now we can test it. It's okay, but with the correct this, open your behavior default, search for the test function, and here call clock UI remove from parent. And now it will work. If I died, the clock is removed. And when I respond, everyone is dead. So, thanks for watching. Sorry for my accent. Sorry for the mistake I did. I'm pretty new to make tutorials, so I know I have to improve it. And maybe see you next time.